So we're going to be answering questions on page 17, but we need the data from page 16. So page 16 should look like this. It has a table. It has a little table down here with our summary statistics, and it has a dot plot. I want you guys to look at this right here. How tall do you need to be to play in the NBA? Well, it depends on what position you want to play. In this lesson, we're going to try to find the average height for all power forwards by taking a random sample of 5 power forwards. I don't remember what year this data was collected, but this was all of the power forwards in whatever year I grabbed this data. What is the population here? What is the population? 115 is the number in the population, but what is the population? All power forwards in the NBA, yes. All NBA power forwards. So what's the sample going to be? 5 what? 5 power forwards. The 5 selected power forwards. Page 16 has the data. Page 17 has where we're recording answers. That's okay. Right. So looking at page 16, what is the shape of the population distribution? What is the shape of the population distribution? Approximately normal. And again, this is about the population distribution. What is the mean? 80.087. We've got our summary statistics. So this would be mu. What's the standard deviation? 1.519, yes. So this would be sigma. So far, so good? Right. You guys are going to take a random sample of 5 power forwards. You're going to record their heights and find the mean of the sample. You're going to do this 3 times over. How will you be picking your sample of 5? Random number generator. What buttons do we push? Math. What's my calculator? Over to probability. We want option number 8, the rand in, no repeat. You're going to pick numbers between what and what? 1 and 115. What's your little n? 5, because we want to pick 5. Now, when it gives you those 5 numbers on the screen, is that what you're finding the average of? No, you have to find it. You go to this page here, you're going to find the 5 random numbers in the left-hand column. What I want you to record and find the average of is the heights of those 5 randomly selected players. You're going to do this a total of 3 times. Select your random sample of 5, write down their heights, find the average. Then do a different random sample of 5, write down their heights, calculate the average, and then do that a 3rd time. Let's see if we can do this in about 5 minutes. If I need to add some extra time on, I can add extra time, but let's check in and see where we are in 5 minutes. Okay, I want you guys to get the basic shape of the dot plot into your notes. Do not worry about the exact placement of every single dot. I want you to get the basic shape. Speaking of basic shapes, if I asked you to describe this shape to me, what would you tell me? It looks approximately normal to me. It looks approximately normal. All right. So the reason that this is approximately normal, and if we had more dots, we would see it become more and more and more normal. The population distribution is approximately normal, so my sampling distribution will also be approximately normal. Thank you. All right, population distribution is approximately normal. If I asked you to give me your best guess for the mean of the dot plot, what's your best guess for the mean on the dot plot? 80 sounds good. The actual mean of the sampling distribution, so the mean of X bar, will be whatever the true mean is. What did we say the true mean was for the population? 80.087. This is the true mean. This is a sampling distribution. Of X bar. All right, best guess on standard deviation. What is your best guess for standard deviation? And then I'll tell you how to calculate it.
Maybe like 0.02.
0.02?
No, never mind. Call it something. 0.2.
0.2, 0.1?
There's a dot. There's a dot about like every.
Okay, so you told me that the mean looks like it's at about 80. We know it's actually at 80.087. But if I look at this right here as my mean, how many standard deviations does it need to go out on either side, approximately? If it's approximately normal, it should go out how many standard deviations? 3. Should go out 3 standard deviations on either side. A little bit more than 3. But 3 standard deviations on either side is 99.7% of the entire area. So if I were to ask you to do this, put the mean here, we want 3 standard deviations this way, 3 standard deviations this way. That'd be about how big? Because 0.2 would take me to here. 0.5? 1, 2, 3, and then a little bit more. I think 0.5 is probably a reasonable guesstimate for standard deviation. The way we actually calculate the standard deviation for X bar, so sigma of X bar, we take whatever the population standard deviation is, sigma, and we divide by the square root of n. What was the population standard deviation? 1.519 divided by the square root of, what was our n? 5. Go ahead and calculate that for me and tell me what you get. What'd you say? 0.6793? 0. So 679? Something like that? Is that what you got?
Yes.
Okay. All right.
You could have just said 0.6.
Yeah, we could have, but we didn't. Number 6, use a normal distribution. Use a normal distribution to find the probability of taking a random sample of 5 power forwards and getting a sample mean of less than 79 inches. What's the first thing I need to do on number 6? Draw. We're going to draw a picture. What is the mean right down the center? What is the mean? What goes right down the center of your picture? 80 point what? 80.087. Standard deviation, 0.679. Where does the boundary line go on your picture?
You need an inversion.
Where does the boundary line go on the picture? Where should the boundary line go in your picture? We've been talking about the picture. Have you been paying attention? 80.087 is the mean. That's what goes right down the center. 79 should be our boundary line. And then which way are you going to shade? Left. So your picture should look like this.
Why did you get 0.679? Oh, that's the actual.
That's the actual standard deviation. Yes.
But we estimated 0.5.
I asked you guys, looking at the picture, what would you estimate the standard deviation to be? And then we learned how to actually calculate it precisely.
Gotcha.
Did you know that 79 inches is 6'7"?
Mm-hmm. What are we going to use to calculate this? Normal CDF. So let's talk about notation. I want to know the probability that my sample mean, the probability that X bar is less than or equal to 79. So we're going to use a normal CDF. Lower bound, give me a reasonable lower bound here. Negative 99 would be fine. 0 could also work here. We're talking about people and their heights. Like if somebody is 0 inches tall, that would be a reasonable lower bound, right? Like obviously nobody is going to be 0 inches tall. What is our upper bound here? 79 is our upper bound. And then we have our mean and our standard deviation. Yeah, using negative 1,000,000 as a lower bound is definitely an absurdly small number. And what do you get when you put this into the calculator? Yes, 0.0547. All right. Let's flip this over.
I was ready. It's just
You were also talking.
I was also talking. There we go.
All right. Quick notes. Sampling distribution of X bar. If the population distribution is approximately normal, then my sampling distribution will also be approximately normal. You do not have to check large counts. If the population distribution is approximately normal, sampling distribution will be approximately normal. The mean of X bar is whatever the mean of the population is. Make sure you check your 10% condition if you are sampling without replacement. You do the population standard deviation divided by the square root of your sample size. In case you need to calculate a z-score, it'd be your sample mean minus the true mean divided by the standard deviation of your sample. Am I actually going to be asking you for a z-score? It is possible, especially in a multiple choice format. Absolutely it is. Z-scores are a fundamental piece of statistics. It is describing how many standard deviations away from the mean you are. You have the basic formula to calculate a z-score on your formula page. Statistic minus parameter divided by the standard error. Let's go down and look at the check your understanding to finish us off for today. Every day, people watch about 1 billion hours of videos on YouTube. That breaks down to every single person on Earth watching YouTube videos for about 8.4 minutes per day. For US teens in any given day, The amount of time spent watching YouTube videos is approximately normal, with a mean of 18.5 minutes and a standard deviation of 5.3 minutes. Find the probability that a randomly chosen US teen watches YouTube for more than 25 minutes in a given day. How do you start this problem? With picture. Start the problem with picture. What shape are you going to draw? Approximately normal. Draw your normal curve. What's going to go right down the center?
18.5.
18.5. What's the standard deviation going to be? 5.3. Where's your boundary line going to go? 25. And which way are you going to shade? Shade to the right. All right, so your picture should look like this. And then what are you going to do to actually find the answer?
Normal CDF.
Normal CDF. Go ahead and do that for me.
We both have 2. Perfect.
Like, we're the only two that, like, everyone else actually has a brain faster.
We're just here for the bit.
I know, yeah, that's kind of, it's the only reason why I took this faster for the bit.
Well, my mom yesterday said that we have a month left of school. What's your job? She's like, you're locking on your schoolwork.
I wish I had.
My strategy is like dissociate until like 5 days before the test and then lock in.
That's what I'm saying, because I've been taught my
No,
entire
she was like,
life that I can
no,
do
the funny thing is she would, the kinds are not good. She was talking to me and my brother. She goes, the kinds aren't good test takers. Except for maybe you two. You guys are pretty good test takers. So I was like, because no, I don't know how I do it. Things just stick in my brain. I'm a pretty good test taker. I don't have to study too much. Like my siblings, my older siblings, they have to like study.
No, my brain's gonna.
I kind of just go in hoping for the best, and usually it's okay.
And usually it's okay. That works.
Usually it's never bad.
All right. What did you get for the probability that they watch for more than 25 minutes a day? You said 0.11? Yep. 0.11. All right. Suppose we choose a simple random sample of 10 US teens. We're going to let X bar be the mean amount of time spent watching YouTube videos for the sample. What is the mean for the sample?
The mean is still gonna be 18.5.
Yes, mean is still going to be 18.5. The mean of X bar will be the mean of the population. It will be 18.5. Before you can calculate the standard deviation, what do you have to do?
Find the
10%. So what do I actually need to write down to check 10%?
P times N is.
That's large counts.
Yeah.
It's 10 is
Yep, 10.
less than or equal to all US teams.
Yes.
10% of all US.
10 is less than or equal to 10% of all US teens. Is that a fair assumption?
Yeah.
Then we get our 10% condition. So then we can actually calculate the standard deviation. So we're going to do the standard deviation of X bar equals the standard deviation of the population over the square root of n. What was the standard deviation for the population again? 5.3 over the square root of 10. And that gives us a standard deviation of what?
Where'd you get the 5.3?
5.3 is the population standard deviation. That's sigma.
Oh, okay.
Got it both. 1.676.
1.676.
There's so many today.
There are so many today, it's not even funny.
It's just, I think it's just today. It's usually not this bad.
So now I want you guys to calculate the probability that the mean amount of time spent watching YouTube for teens in the sample exceeds 25 minutes. What do you need to start number 3 off by doing? Draw a picture.
Did you get the wishbone?
What goes right down the middle of this picture? 18.5. What's the standard deviation here? 1.676, not 5.3 anymore. Now, because we have a sample, it's 1.676. Still 18.5 is the mean. Where's our boundary falling? 25, and we're going to shade which way? To the right. So this looks very similar to what we did before, except this is different. Standard deviation is the only thing that's different here. So now I want the probability that X bar is greater than 25. Lower bound, upper bound, mean, and standard deviation. What does this one come out to be? Ooh, what does the E mean again? Scientific notation. Which way do we need to count with this? Yeah, we need to add zeros after the decimal point. Add zeros after the decimal point. Yep, five places, so 4 zeros, and then our first number. So what changed between number 1 and number 3? It got a lot smaller. Number 1, we said, what's the probability of picking out a single person that watches YouTube for more than 25 minutes? We came up with about 11%. This is, what is the probability of taking a random sample of 5 and averaging all their times and coming up with an average that's more than 25 minutes? Now we have a much smaller probability. New homework is due on Friday. New homework is due on Friday. Have a good one.